and we'll go through rows of buttons and dials here for features. The first one up here in the upper left is a program of downslope on your 2T or 4T programming. We're going to run off of a foot pedal today, so we're going to stay on 2T. If we plug this in and just use the contactor on the torch, we can program a downslope. I do believe that downslope is in seconds. So if we were making a repeatable procedure type weld or a process weld, and we hit the contactor, we come up to our amperage, we hit the contactor again, it would go through a downslope of amperage for whatever seconds we have dialed into it. The second one is pre-flow off over here. We have it set to 0 because I'm just going to be running beads on carbon steel and aluminum. When we get to aluminum, I could do the pre-flow. If I have it set for 2 seconds of pre-flow, that means it's going to flood my arc area for 2 seconds before it allows the amperage to come on. It's pretty simple. It's kind of so I'm going to go ahead and set it down to 0. Post-flow is your argon flow after you terminate the weld. I normally set mine to about 8 to 10 seconds depending on the size of tungsten that I'm using and the amperage that I'm welding at. I'm going to be using 3/32 tungsten today, so I'm going to set it at about 8 seconds or so.
On the side of the torch, I'll have to chip that out. Alright, I'll have to fine tune it a little bit just so it's a little bit bigger. I want to be able to drop this pin through that. Oh, it goes through. Maybe I'll leave it then. Okay, good. Now I just need to get a bolt for that. I'll clean up the other sides, then I'll get it burned in. So for this little project, we're using Hobart. This is kind of the generic Hobarts from Tractor Supply. They're 1/8 7018 and 135 amps, which is probably a little more than I need to use, but it worked well.
Not enough welding, so let's get to it. All right, this is the setup I used for one end of the parts that I did. A little over 170 amps, DC, no pulse. Set on 2T, and I just used a torch switch, and I walked the cup on a positioner. So here's a little preview of what that looked like. This will be in detail in a video coming pretty soon. You know, the DC arc is as smooth as any. You don't see a lot of difference from one inverter to another on the DC arc, except when you start getting into pulsing and things like that. So this is just like I expected. DC arc, nice and smooth. No downslope though, so in order to stop, I kind of just had to speed up there and just turn it off. The family meek and mild. Singing a little Merle Haggard there while I was working. Alright, so I got about 20 of these parts done. I got 30 more to do, and there's some other pieces that will go on there as well. This is the torch that came with the unit. It's an air-cooled 17, set up with the pretty typical hardware. I think that's a number 5 cup on there. It's got a torch switch on it. And you can take that off. You can snip the zip ties, totally remove it, take it loose, or you can just double it back, tape it to the cable a couple of feet down to get it out of your way in case you do want to use it. I like the stubby kits on these 17 torches. I sell these at my online store, and the reason I like them is just because it really shrinks the torch. It really makes it so much more maneuverable. It feels better in my hand, and I can get up inside things if I need to. To me, I just like it. You know, nothing wrong with the other style, but if you got to stick it up inside a pipe or a piece of square tubing or something, it lets you do it.
All right, so now let's take a look at the welder itself. The front panel here is pretty simple. It's all pretty self-explanatory. You have an amperage gauge here, which shows you what the set amperage is. I don't know yet if it will show what the welding output is during welding. I haven't actually powered it up and started using it yet. You do have a little power available, or power on light, and an over temp light here. Just a basic rocker switch here to switch between TIG and stick modes, and an amperage dial, and this is smooth, infinitely variable knob. No real issues here, nothing jumps out at me. One thing I do note is that this sticker is kind of popping off, but that's no big deal. Now down here at the connections, again, pretty simple. You have your negative and your positive DINS connection outputs. You have your control connector here, and this is the gas outlet, but it is also the TIG torch amperage outlet. This is where the TIG torch is going to get its welding voltage and amperage. And really the main reason that is of note in terms of the welder itself is just the fact that this is sticking out pretty far. It's not shielded or covered or anything, so while you're welding, this will be live. Just something to keep in mind. You know, you wouldn't want to bump that on anything or ground that out while you're welding, because this would be hot. Side of the welder, nothing too exciting there. You just have some vent louvers, Amoco power label, and that's pretty much it. Nothing too exciting there. And now we have the back of the welder, and this is where things start to get interesting and actually problematic. On-off rocker switch, nothing too exciting there. You have your cooling fan here. I measured it, it's only about an 80 millimeter cooling fan, so that's actually pretty small. You know, computer power supplies have a fan about that size, so it doesn't necessarily mean anything, but just comes back to that whole 60% duty cycle at 220 amps being kind of questionable. First issue I noticed on the back is that this fitting for the power supply coming in is actually loose. It's just, it can just totally flop around there. You know, I don't know what kind of stress is being put on those cords inside, or if from this rotating, if it's pulled anything loose or anything kind of messed up there. So that's the main reason I want to pull the case open. Make sure the power connections aren't messed up, make sure everything's connected, everything's solid and secure before I go plugging this thing in.
Our collet body. So our nozzle screws onto the collet body. How this all works, it goes through there. When you tighten the back cap, it pushes on the collet, tightening the tungsten into the collet body, making it so it doesn't move. So our tungsten's got a good stick out on there. We're gonna have to sharpen that. But we're basically ready TIG weld. So going back to the 215 home screen here, we got a 3/32 tungsten. That's what it's asking us. We got a remote plugged in. It's telling us yes. It says 18 gauge. We can increase that because we're going to weld on some, maybe some, just see, we got 1/4 inch. We're going to try 1/4 inch material, and then you can adjust it accordingly. There's the target setting, or you can go all the way up to that. We'll go with the target setting. So notice it says TIG lift arc remote. So this unit does not have high frequency. High frequency is an assist to jump the arc across from the tungsten to the base metal to help initiate the arc. This does not have it, so we're going to have to touch the tungsten, pull off. It's called lift arc. I'll show that here. Let me sharpen the tungsten. We're all set up. Got my tungsten sharpened. We got 3/32 tungsten, 1/4 inch material. Target setting is 175 amps. Let's give this thing a shot. Now remember, with lift arc,
Yeah, I got a little bit there I didn't go through.
Okay, so I'm pretty sure they can run this way. We'll find out. So what I need to do now is turn the machine on. I've got it plugged in. We are on. And I need to put it, it's in TIG mode already. We've got stick mode for arc welding or TIG, so it's in TIG. And then we need to turn the gas on. Okay, that is on. Then look on the flow.